All right, so the Maid lathe. Well, we'll go back. Maid lathe. We started in concept on this about 2010, and it really started with a conversation about this piece, and this piece here is the headstock retractor. And Al Collins and I had a conversation about making a headstock retractor, and a long discussion, and it turned out to be the prototype of this. And I wanted it to have change gears, which we have here, which we can turn, 1 to 1 and 1 to 3, 3 to 1, 2 to 3, whatever we wanted. As long as you have the same total number of teeth between the two gears, you can put any ratio in there you want. So that led to more conversations, and we took this to the Ornamental Turners meeting in 2010 out in San Jose, California. And shortly after that, we had another discussion, and I guess he wanted a heavier headstock, so much heavier headstock. And he says, "Can you think we can make a headstock?" I said, "Let's just make an entire lathe," as if you just do that. Here's another shot of the headstock retractor. And it's made so you can engage and disengage it with the handle here. You can lock it in here. This handle raises and lowers the worm wheel, and the worm. The worm goes up and down inside or below the worm wheel, and you can engage, disengage, and all that. And what happens with this wheel is it moves backwards until it disengages from the back. So you essentially don't have your machine go till it's, till parts fall on the floor. So the two of us probably didn't have the facility to do it all ourselves. Al's a cabinet maker, and he can handle the cabinet making. And I have a small machine shop. My biggest lathe is 13 inches, but I certainly can't swing that big flywheel and some of the other bigger parts and turn them. So I said, boy, we're going to have to consult somebody else that's a little bit half off and twist their arm until they succumb. And we got Mike Stacy, who's here on the right. So we have David, Al, and Mike, and we figured, we'll make the damn lathe. And then figured, well, the more the merrier. So we invited Eric into it. Eric is here, Al's here, David, Eric, and we certainly weren't going to call it the Dame lathe. So we called it the Maid lathe. Mike, Al, David, and Eric. And 2 years after we really started doing it, we had the first prototype made. Al had made the base. He had also made the casting patterns. I think he had made a lot of those casting patterns for the lathe he made, 10 years previous or so. So, off we go. And Mike handled the bigger parts, I handled the smaller parts, and we all kind of shared in the design work. This is a photo we took shortly after we assembled it here at the Plumier Foundation. And in the years since then, we have never had one sitting in a place where we could get good lighting and good photographs of it. And these photographs were all taken by my wife, Becky, and processed by her, etc. So the thinking behind it was heavier because Al got into fixed tool work. I think he got that bug bitten by Jeremy Soulsby's lecture in 2006 at the Portsmouth OTI meeting, and wanted a heavier lathe. So everything is made kind of ridiculously heavy. The bed is over 250 pounds of cast iron. The flywheel is about 120 pounds. The Headstock, all assembled, is about 220 pounds completely assembled, everything on there. Just the barrel section is nearly 90 pounds. It's an extremely heavy lathe made to do fixed tool work. Now, it can do anything else as well, but for fixed tool work. And you'll see higher amplitude rosettes as we go through for it as well. But if I wanted to take the spaces between the spacers and put guilloche rosettes in there, so we could do guilloche as well. So the headstock retractor mounts to this bar here and goes against the headstock at the center level. And we'll talk about different features of this as we go then. We learned a lot along the way. One thing we did is we copied Fred Armbruster, and he talked about this in the 2006 Portsmouth meeting as well. As he used a piece of Thompson tubing for 5C collets. So we took a piece of Thompson tubing, and the pain of Thompson tubing is it isn't actually round. They have about a 1/1000 tolerance, and it is egg-shaped, which is kind of a challenge. You kind of got to hone it in a little bit. It's not too egg-shaped, but you bore it out and you put a 5C collet adapter in it, and then you have interchangeable collets there. We put an additional over here underneath the touch stand. We put an additional headstock leveler, so we could, with a lead screw, you can push the headstock out, and then you can do fading and so forth with it. Just a couple of the features we added. We wanted it so we wanted oil cups at the top that were attractive and constantly fed. So we really like the Lunkenheimer brand. So we searched out old Lunkenheimer oilers, rebuilt them, made them so they didn't leak, because most of them leak out of the box, and employed them. Down on the drives area, you'll see the pivot is here, and instead of using 2 points like you usually see, we wanted a heavier rocking system. So what you have here are 2 pillow blocks, pillow block here and a pillow block here, with bronze bushings in it. And then here, this is the bottom of the headstock casting, and it's cinched to a 1-inch piece of Thompson rod, hardened solid rod, with a set screw. So there's preloaded wave springs inside of here, and you pivot off of that entire bar, pivots in the pillow blocks rather than just 2 points. And that has turned out to be a good decision, because you got a lot of weight there, and you need your mass transfer is much better than on 2 little points, and we're happy with that. Our first flywheel shaft was 1 inch, and that was way too small, and that rod warped. So we went to 1.5 inch, and that beefed it up quite a lot, and that did the trick there. That does not warp anymore. But again, this flywheel is about 120 pounds when it's cast. It probably goes down to about 110 when it's done. And Mike does that on a big Bullard number 3 vertical turret lathe. Traditional belt tensioner or elevator, if you want to call it that. Same thing with the belt tensioner here. So the flywheel moves up and down with this mechanism to tighten this belt, and then this belt here is tightened with this mechanism. This here is goes to a cone. It's a cone bearing on the end of this rod, and you'd think it would need to be very heavy, but actually most of the weight is handled right here, and the ballast of this bar is almost enough to keep that equilibrium. So you're really holding very, very little back with the other end of this point. Our nuts, and I shouldn't say nuts, our washers and our bolts that hold the barrel nuts on the other end of them, those were copied from Evans, because we just simply like the Evans style and copied that. When we brought it to Plumier, this is us putting it together. This is Bill Ruprecht, the founder, and this is Christian, my son, and well, that's me. We invited Frank Dorian down for the occasion. Frank's been an enormous help to us and volunteered a lot of hours. And, it was kind of a big deal. We'd waited a long time, and he's just a general smart guy that keeps us from making a lot of mistakes. So we were pretty glad to have him there. Now, one of the features, I don't know how many times we're going to see this in the picture, is right down here on the back of the headstock. You see, these are canister springs. We have the big leaf spring in the back like you normally see. We have canister springs. And the reason for the canister springs is because we can turn up the spring tension very, very high, much higher than we can just with the leaf spring. And you'll use that a lot of times with fixed tool work. So we can really like push hard on the whole thing, and you can make some time with it. So.
Just a quickie there, David. Do you think you could get rid of the caption at the bottom of the screen for us? You've got that one.
Hide, it says. There you go.
Yeah, great, thanks.
So the deal with this picture is this is my son, and the presentation was pretty well put together by my wife. So you can pretty well imagine why that picture's there. My son is he's the backbone of the place when it comes to labor. And he knows these machines exceptionally well. He can make about any part on here, and he knows the assemblies as well as anybody does. So a proud mother is the reason for that one. Here are a couple of full shots that she took of the lathe. 3 motors. This is the drive motor, and the belt's off of it because she said it's a distraction in the picture. Belt's over here on this one. But that's the drive motor for the pulley. We could drive it from here to the headstock too, but it seems to me to be smoother when it goes down against the flywheel, and the flywheel turns. For whatever reason, that seems to be smoother. The second motor in the middle is on a linear bearing on a piece of Thompson tubing. This is a hardened, case hardened shaft at the top. And again, we followed Fred Armbruster at that, and that just rolls as smooth as silk down and back. And it follows your cutting frame rather than having your belt go at an angle. This top bar is we call it the safety bar, because if you let your belt off of your cutting frame, that goes up and hits there rather than crashing into something else. This motor on the right, that drives this pulley right here, which is part of the auto drive for the slide rest. So that's the auto drive there. Other than that, I think it's pretty much self-explanatory. And this is the slide rest. For those not familiar, it's that part there. So the slide rest, the design of this slide rest was in large part that Al made the casting models for the bottom and so forth. We patterned it more or less after Holtzapfel and some things after Evans, except for the drive system on the end. The drive system was completely designed at Columbus Machine Works by a guy named Jerry. I don't even know Jerry's last name, but Jerry was in his 70s, and he kind of took on the project as his own, and he pursued it with all ardor and so forth. The features of it are, we set these are thousandths of an inch, so you can measure up and down by the thousandths with a Tommy bar adjustment. The touch for the curvilinear slide has interchangeable heads on it. You can here or over here, you can see you put different diameters, so you can match the diameter of your cutter or not match the diameter of your cutter. But with that, you can create shapes different than the shape on the piece. Now down here, you'll see a turret screw here and a turret screw here and one over here, and those are your adjustments. for your gibs, but both sides are adjustable. Now, it's a double-edged sword. Usually in these machine tools, you pin the one side and then you adjust the other, but as it wears, it usually doesn't wear square. This way you can adjust it out. You can make it square with the bottom bed. And of course, the downer on that is that you have to make it square. It doesn't automatically go there. So it's good, and then you can adjust it out to anything. And if something goes bad, you can adjust it out again. And it's bad that you have to adjust it out. It's a pain in the neck. But like Holtzapfel, we made the piece removable here so that the slide can move forward and back. This and this down here are stops. So it has auto stops for both left and right. It goes either way you go, you have stops. And you have stops here that you can butt up against. But these are for the auto feed. These are the auto feed stops. This whole bar moves and then releases the piece. This is the piece that releases right here. So if you want it to stop, you just push in or pull out on that button either way. And this piece here drops down and it disengages the worm from the worm wheel. The dial here on this end, we graduated the dials on both ends, because if you're working in the face mode, it's hard to see this dial on the other side of the lathe. This is adjustable too, and that design was done by John Spencer, who put a nice little spring system and a circlip in there to keep it from releasing. This lyre system, Mike Stacy designed for the most part, and a weight hangs off of it, and you don't have to stand there with your hand on the handle the whole time to run the curvilinear. The knurled knob allows you to adjust it in and out, or to pull it out and lock it in place while you make other adjustments. But that auto feed there works great, because you can actually turn the thing on and walk away. To the rosettes, we see very high amplitude rosettes here, and in the one I was going to use at Plumier, I wanted low amplitudes and high amplitudes, and the more interesting shapes I will use down here on the left side on the auxiliary rosette holder. I use these more than the more interesting shapes personally, and I really like these low amplitudes. For fixed tool work, you use a lot of these high amplitude rosettes. The shape of our touch holder, anyone that's familiar with Lean Hard is gonna see, boy, they copied Lean Hard, and that's exactly what we did. If you see a good design, you're not going to improve much on Lean Hard's design. It functions exceptionally well, and it looks really good, so we went with it.
Quick question there, David, from Kurt Strello. He's inquiring about the engraving. Are the dials hand engraved?
No, we actually engraved them on a pantograph engraver. Pantograph engraver. All these dials, we set up a pantograph with a little indexer. I actually use a Sureline CNC indexer. It's the only CNC thing in my shop. And, do it with them. We'll look at a couple more of those numbers in a minute. Again, the Lunkenheimer oilers, it's just, they are so beautiful. We just had to use Lunkenheimers. You can also, if you see here, there's a little flat section. I did that and put the hole here so that we could put a detent down, and you could have a little click system, so you could phase, a very fine phasing for different things. Here's a close-up of the auxiliary rosette holder, and these are double line century numbers here, a little arrow, and again, this is made so you can unscrew that and release this worm from the worm wheel, and you can rapidly index. And the intention here is to use this auxiliary rosette system to hold gears for a spiral, so you'll be able to have a rose engine with a spiral simultaneously, which is kind of a cool option. more, you can see a little pad, and I moved the point of contact down to about halfway so we could lift that out of there a little easier. But it's spring loaded underneath that pad so that, you know, if you're doing spiral work, it doesn't jump out, and you can but if you're doing heavier fixed tool work, you can screw it down and have it really close. Again, those are the double line numbers. It does quite nice work for a pantograph. You know, when I first started, I was wondering if we were going to have those hand engraved or not, but it turned out we were quite pleased with what the pantograph did, and we actually fill them with fingernail polish, black fingernail polish. Do not buy the stuff from the dollar store. You got to go to the $2 fingernail polish, $2 or $3. You'll see things like these blued screws. That, you know, here's a blued screw. Here's a blued screw. That comes right out of my horological training. I absolutely love the color of blued screws, and they're all heat blued. They're not chemical, that's heat. We do them on bluing salts. Up here, you'll see this. What I find it quite annoying on a lot of these older Rose engines that there's no spindle lock. So you go to tighten the 5C, call it down, or go to knock a chuck off or whatever. And, you know, you're grabbing a hold. You don't really just want to grab a hold of this because there's a little set screw holding. Even on the old Holzapfel we have, it's just a little set screw holding it all tight. You really don't want to put all the shock there. So what this does is it pinches down from the top and bottom like a tailstock on an engineering lathe. And you can tighten that screw, and it doesn't take much, and it pinches that spindle tube and locks it so you can take chucks on and off. This is the cam ring for the elliptical chuck. The little plate in the back for setting it is there, setting the offset. Now there are 5 screws you see here. And the reason for those is every one of our Holzapfels, except for the one we had to modify, this cam ring is not concentric top to bottom. You can always adjust it left and right, but you can't adjust theirs top to bottom. So I wanted adjustment in that ring so we could zero it out. You know, now you can put an indicator on, run the indicator around the outside, and dial it right in. To screw on the elliptical chuck, we took a 5C back, they call it a fixture, and we machined a 1-inch 8 on there. Mike's shop made quick work of that, and quite nice. And here's the elliptical chuck. Now, I don't know how many of you are from, when you see this, you're going to start recognizing parts, but this is kind of borrowed from Neuweiler. William Stahl, Neuweiler, that kind of thing. They use this kind of leveling system for their straight line engines and so forth. So we've copied that from there. Part of the design was copied from Plant. Part of the design was copied from Lang. Part of it was from Field. We really copied a lot of different things and incorporated them into our own. This one here, we also put 4 turret screws so that we could align it, move it up and down, so forth. So if you're, as it wears, you can adjust it up and down so that this way system is on center with this mount. These paddles here, or pallets if you want to call them that, the contour to the shape of the cam ring, and that gives you full contact all the way around. And after the lectures I got from John Edwards, I'm sure he'll be glad to see that on here. But because it really is way superior to only having 2 flat paddles, because the 2 flat paddles wear right in the middle, and every one of our Holzapfels had to be dressed here at the foundation because they had worn, just like he said they would. They wear when you're idling. And then this screw goes down into a slot, so these have to be able to freely slide left to right, and that's what happens there. These are oil ports, and below that are also slots with felt in them. So you fill them with oil. The felt absorbs the oil and then releases it slowly. You know, it's adjustable here and here. You can zero it out. And here it is on the machine, being dialed in. And this is what we put into the leveling system to mount the 1" 8. If you're doing engine turning, you'll use a different thing, of course, but you can put any thread in there, any system you want. Here it is mounted. The scraping here, by the way, all this scraping was done by Josh Uther. Josh Uther did the finish and assembly work on this entire chuck. And, he's a Uther Machine if you want to look him up on Instagram. Here it is from another angle. Again, it's just incredibly heavy. Everything is very, very massive, heavy, and still operates as smooth as silk. So we got the machine together, wanted to try it out, and I did this as a pumping pattern. And, here you see, there's the cutting frame I used to do this pattern. And kind of what I'm always trying to illustrate is how pumping pattern just about imitates the reciprocator patterns that we were doing on the Holtzapfel lathes, and depending on amplitudes and so forth. And you know, you can do a lot of things a lot of different ways. You don't need every single tool to do these things, and if you have them, that's great, but a lot of times we don't have them, so we got to make things work the way they are. And here's that box. It's one of the, I think it's the second box we finished on the lathe. We did all the patterns on this. I did on that lathe, and we were testing it out. And these are different components, by the way. The top screws off like you see here. And this is a piece, and this is a piece, and this is a piece. And partially we did that so we could study the aesthetics of different lids, different bases, and see how a 32nd of an inch changes how it looks. And it really made us a lot more keen on making the moldings, getting these shapes up in the tops and the bottoms and the transitions right. I highly recommend doing that, even if you're not going to do it largely. Do a project where you do that to study it. I also did the inside, which you can't really, here you can see it a little bit, inside of the box, what I also did on the Maid lathe. Here's the first real project I did on it. And it comprised of doing a 1/4 inch amplitude, 24 bump. And we created the pumping rubber to make the sine wave, because it was a C-shaped rosette. And then it came back in with one of Chris Plouffe's purling tool cutters and landed that between all these. And there's the finished box. Copying something out of the Plumier book, I just thought that'd be appropriate to do. Take our new lathe, such an old book, and revisit a pattern that's been around a long time now. You really study this out, you're going to probably find that it's almost impossible to do this exact pattern, but it's not far off, is it? Not too bad. And we did it with a drill. The drill made the basic shape, and then came back in with a purling drill to put the balls into it. Before we had the Maid lathe, we wanted to do this pattern here, but my amplitude was too small on my little Lindow machine. So this is what we came up with, and it's a lovely pattern, I think, just as well. And it's made simply by 2 cuts that are you'd call parallel, and then And I think we went 1¼ millimeters or 50 thousandths of an inch over, made the second cut, and then we moved over just bigger than the amplitude and phased 180 degrees and did the same thing and did that alternatively all the way down. My son made this box, Christian. And then he employed it on the side of an elliptical shaped box. But instead of using the drilling frame, he used the universal cutting frame set vertically. And he came up with this, and it's a much more linear pattern. I think it looks just as good or better. But that's how he came up with this. And just did the same thing in an elliptical shape with the universal cutter. He did this with a little ball cutter, and if you notice, it's undercut. Under the outside edge is undercut. And what he did, if this company, Harvey Tool, you can buy a ball cutter that has 300 degrees of cutting surface. So you can actually get back underneath lips like that. And, you know, he used the eccentric chuck along with the elliptical chuck and moved his slide rest over just barely more than the eccentric chuck every time. And so anyway, we're going to go back a little bit and talk about these boxes we made. And
just before you do that, David,
sure.
We had a question from Dale Schlocknick. How do you get an even pattern on the side of an elliptical box? Some kind of elliptical dividing mechanism, perhaps?
Well, if you notice, so they're big here and they're little down here. Well, we did that with the Rose engine, so there really isn't any. You're not really going to fix that problem. You can't, you know, you're not going to create a compensator for your Rose engine, and probably the patience it takes to do the compensator on a box like this is more than my son and I really probably are going to have patience for. So we just, I don't think it looks bad with the difference, but no, we just lived with the difference. And of course, my wife's a great photographer, so she makes our stuff look better than it actually is. But no, that's just, it's just on a Rose engine, moving left and right as it's pumping, and then you get the elliptical shape while it's pumping. So that's it.
Okay, thank you.
So more or less that kind of, I'm going to go from the Maid lathe to these boxes, and these boxes were some of the first ones we made here. So these, Bill had the idea of making some pill boxes, and he was going to put them in sets of 7 and so forth. But as much as anything, we needed to test out the machines. We needed to figure out what screws were broken, what was missing. So the other part of it is my son had never done any of this work before. I mean, he had been in the machine shop since he was 9 years old, but he's never done ornamental turning. So we needed to get him acclimated to the machines, get him understanding how to set things up, how to do things, and get him to where he could show people how to do that when they came here. So these series of pill bottles was to do that, to get us doing a little better aesthetics, getting us using these things effectively for looks. And this was Becky's early photography work, you know, some of it. So we look back and we're like, we're not as excited about it as we were when we took pictures. But if you do look back and you think your work was great, you probably haven't improved. So we're pretty pleased to even show you these. Gotten a lot better at a lot of things, but this is a piece of Mopani. This right here is a piece of Shock de Viga, and I really like that orange color in that. And what we'll be working with very shortly is we'll be stabilizing that with plasticizing essentially, because Shock de Viga is a little bit on the not dense enough side. And, here's a piece of cocobolo. So, so that was done on the spiral attachment on number 2157, and we went to the curvilinear attachment on the same machine. And this is kind of just a happy accident, you know. Fell into this design, and I kind of liked it, and I, you know, made up 6 or 8 of them. This pillbox, by the way, has a drawn and spun rim of the drawn tube inside of it. It's silver, so that your pills don't sit up against the wood. But again, this is Shakta Viga, Mopani. I don't even know what kind of wood that is. It was supposed to be iron wood of some kind. Cocobolo, and this is also Cocobolo. That's just simply set up with a curvilinear and a universal cutting frame going along here, and left the original cylindrical shape here. And you kind of get that teardrop shape. And testing out the tools once again. These indexed patterns, these were done, this and this. These were done on number 2410 using the counting index, where you squeeze and you move back, and you get just as fast as you you can squeeze it and shove it back, and as you squeeze it, it drops the detent into the one area. You push it back, you release it, it releases that detent, engages the other, and then you pull it forward. Frank Dorian liked it so much he went home and copied it. But we're also testing out different materials here. We're using faux ivory from a place in Connecticut. Really like the grain structure in it. But this here is stabilized holly that I had gotten a couple years beforehand. My son had begun to explore the reciprocator here, and he was doing double cuts on top of each other. So this is really was probably the first real pattern he did on the reciprocator after tearing into it. Kind of impressive in my mind, but then again, I'm biased. This was just a simple thing I was doing to study some proportions and so forth, and some of them I like better than others. I didn't really care much for this one, but I really like this one quite a lot. You know, and then we were setting up the rocking and the number 1636. We were setting that up, so we started doing some lids with the eccentric cutter and rocking, and I'm very pleased with how it came out. But you know, you move forward. These, we'll get this back to this toward the end, but I stacked 3 chucks up to create this shape right here. It's an elliptical shape. I put the elliptical chuck on, but I put the rectilinear chuck on after that, and I timed them out so that it would I could hold this in the dome chuck and create that shape. And I made up a little drill to create this, and piece out of a piece of carbide, and I just ground that drill on a little watchmaker's lathe. And we began to explore ellipses. You know, we were the elliptical chucks, and these are the kinds of things we were doing, simple things, in order to find out, boy, it sticks. And you know, you find out that wear that John Edwards told us about, that was causing no small amount of grief. I'm also looking to experiment with little things like at the bottom here, how this flares out. You know, how much flare is good there. You know, this one in the back went straight down. And what do I like better? I don't like how short this is versus how long this is. And the same thing with the lips up here. You're experimenting with what looks better, what looks not better, and then you'll carry that into other pieces. Very shortly after that, my son picked up the geometric chuck, and he started playing with that. And again, you're testing out different patterns and different ideas, and he began putting a universal cutting frame in and doing this. At first he was doing, and I don't have any pictures there, but at first he was doing just geometric patterns like you see most of the time. This was another pattern he came up with. This is about his 3rd pattern on the reciprocator. And basically I told him, go figure this reciprocator out and come up with some pattern you like. Well, he didn't so much like the patterns he was seeing. He created that, and he calls it shark tooth. Down the road of an ellipse, I was trying to get bigger and bigger stuff. This is over 10 inches top to bottom. One of our members gave me a couple burls. I had risers for number 2410, so I hiked it up in the air and started doing this bowl just to see how far I could go. I thought I had a picture of it in the lathe, but I don't. But using the risers, wanted to get used to that. There are two sets of risers for this lathe. One, they were for the spiral spherical slide rest that's with it. Needs a riser to function because it's taller. It's a 6-inch, and the lathe is a 5. And then we go down the road of the elliptical thing more and more between my son and I both. He really got into these geometric patterns like this. This is all pretty simple once you understand how it works. This here, but it takes a lot of cuts, and you have to move things around and change the diameter setting on things, and every one of those adjustments you have to nail absolutely right. And if you look at how evenly he got it, that's the key to making him really look good. Because if you really boil it down, it's pretty simple to do that in concept, but it's really difficult to keep your attention span long enough to pull it off. He began to, he says, well, these shell patterns that happen in nature have two sides to them. So he made a double shell instead of just the single you saw earlier. And again, he begins to experiment with using the Rose engine to create the basket weave as opposed to that quick indexer that we have for number 2410. And here's a combination of his work and mine. I was given some Honduran rosewood burl by one of our members and kind of put that to test. And here's some early pumping I did on the Maid lathe. This was an early box my son did with that quick indexer, and it's just a beautiful picture Becky put together, making us look better than we actually are. And again, the 3-dimensional shell he came up with, he was put about testing the chucks on the number 1636, and this was his early one. He used a universal cutting frame on this one. Eventually he went to drills because the drills gave him a little more definition, but he hadn't seen anything done with 3 dimensions. So what he did is that's when he started creating the 3rd dimension and bringing the tool out every cut. And mostly, I think it was the test of the tool. But you got to have ideas, and we aren't that creative, so you tear into Holtzapfel. And if you're going to teach people how to do this stuff, which is the intention here, is to teach people how to do it, you need a pattern to follow. You need a model. And Holtzapfel, a lot of people are put off by the language, but if you learn to penetrate the language, put a little effort into it, you can penetrate the language pretty quickly. And all those patterns he did are pretty well described in Holtzapfel. Now, between that description and him telling people how to do it, you can teach this stuff pretty readily. This looks like it'd be really difficult, but when you boil it down, it's nothing more than a bunch of elliptical lines superimposed on top of each other. And here's where he sees this. So he takes the book, assimilates the information, and then uses it aesthetically and artistically. He thought it'd be kind of cool to have an orbit with a little satellite, a moon, so to speak. So you have your Earth and your moon, or your star, your ring of Saturn, or with a moon of Saturn, or whatever you want to do. But he started experimenting with different means of doing that. So he turned it into 2 angles and created that as well down in the bottom. You can see he started, I use the word concentric, that's the wrong word, but he's concentric to the outside of the ellipse, and he is using an eccentric slide, and he's moving this eccentric slide one amount and moving the slide rest just a little bit more, and that's when you get the center here, the outsides here, and it's concentric both places. This name here, there's a company out in Indiana that will make you your logo or whatever for your pantograph. And what shocked me, I was messing around and I figured we were gonna have to have a live tool, but there was actually in the machine was a diamond drag tool. I used that diamond drag tool, and shockingly, I like the diamond drag tool in wood very much. I don't like it in metal, but I like the diamond drag tool a lot in wood. It sets its own depth, and it's actually no mess and very, very quick and easy to put your logo into something. And I think that template for the machine was $50 or something like that. Wanted to do some experiments with different epoxies and woods. So we stacked up some woods and got about a 2/1000 tolerance. This one went great. The other one I did with boxwood blew into pieces. It just, I put too much pressure on putting it together, and it blew the sides right out of it. These layers, the pink ivory and the next layer of blackwood is 50 thousandths thick. So it's 50,000 or 1 1/4 millimeters between it, and that's it. I mean, this is that thin, but it looks that wide. And Boynia burl here, blackwood and pink ivory. Again, testing out processes. The insides of the boxes. Here with this one here, I was trying to see would it look better as a C shape, a D shape, or as a sine wave? And in the end, I concluded the sine wave really looks the best inside of a box. I really, you see that kind of traditionally in glass work and all kinds of things. I've seen other ornamental turners do it. Nothing new in the design, but I didn't understand the execution well enough. So we went down the road of experimenting. You can see out here, it's a sine wave. And when you start studying these boxes, that's kind of what you look for the sine wave. And these boxes have lids that you can screw off and screw on, and you can change them around and so forth. So Becky liked the looks of the insides of all these boxes and lined them up together. Here's one of my son's early geometric chuck jobs with the drilling frame. You look at the finish he's getting, and that was done on Holtzapfel number 1636 with the geometric chuck. You need to have your head on your frame really tight to get that. So here we go to reciprocator work again. And actually, before long, I'm going to demonstrate, not today, but in what we're working on, we need to demonstrate how you do this exact pattern pumping as well as with reciprocator, or you can get something really close to it with your straight line chuck. And if you understand how those patterns form, you can translate that to all sorts of different, whatever you have available, you can do it on that rather than one or the other. And there, for which one job or another, there may be an advantage to one or the other if you have both, and understanding that's a help. But this is drill work, and this was all done on Holtzapfel number 2195. Long process with that. And there's a formula you can follow to get this pattern, and that is your number of divisions, which here is 3. You're making 3 cuts. You start at 0, 1, 2, 3. Again, 0, 1, 2, 3. You take your amplitude, and you divide it by that 3, and you move your slide rest over that much, or that's on pumping per se. And then you take your wavelength, half your wavelength, and you divide that by 3, and you get this. Whether you'll always get this thing if you do that. And we'll lay some of that out here in the near future, because if you can predict results, you waste a lot less wood, and you're just a lot happier to go in your shop if you're getting good results. We got some step drills. And, well, actually, this was not the step drill. That's another thing he did. But what he did with this is he created oh, this is the step drill, actually. So he used the step drill to create this pattern with the geometric chuck. Execution, I think, it's just so clean. He's just gotten it so clean, which means that he's got the lathe tuned in, got his drilling frame tuned in, and he's understanding how the chuck functions very well. And he will demonstrate that at our fall gathering in October. Show people how to do that. Here is this pattern pumped on the Maid lathe with a 24 bump rosette with a amplitude of 1/4 inch. And here it is. Sorry, no, this is actually, I don't have a picture of that. This is on the 2195 as well. And he got around almost to the end and did this. And that was that. And he started over. About 4.5 hours down the drain. Here's a bunch of boxes that Becky took a picture of that we made. And again, this was another one of the real early reciprocator jobs. We're trying, just getting him acclimated, my son acclimated to using it. But this was an elliptical box, a large one. And I'd say large, it's probably 4.5 inches top to bottom on this. And I did this with one of our volunteers, Anthony Nappy, who comes in pretty regularly. And over the course of months after we did the pill bottles, we went to the bigger one, and it required 4 chucks because the dome chuck or the spherical chuck wouldn't extend out far enough. So we have the elliptical chuck, and we put the rectilinear on, and we timed those out so that the elliptical shape is in the right portion of the box. And that's really pretty easily done. We'll get instructions written for that before too long. You set this chuck up at 90 degrees to this one, perpendicular to that, and then this is parallel to this chuck here, and it allows you to offset and get higher. And I didn't think this would work, actually, but it actually worked really, really well. It was smooth and solid, and that tells you there's not much tool pressure in these things. So I was very pleased with how that came out. And if you go back and look, I mean, if you look at the finish on the side, you see it's pretty good. And you have 3 small cuts and 2 big ones, 3 small and 2 big, and that's how we came out to 0 again. Here's a pattern my son was working on recently, and it really looks pretty crazy. It's a bunch of patterns superimposed, and if you look here, you'll see it's just a simple rose pattern right around here where I'm going. And he just indexed around. He's learning to use, here's the second one, here's the third one, and he's learning to use that the eccentric chuck. But the big thing is every one of these cuts has to be at the same depth, which means your piece has to be dead flat on the bottom. And when you index around, you can't be deeper with one than the other. You've really got to have them come together. Otherwise, these spots like right here, and anyone that's tried that knows exactly what that challenge is. He's nailed it. And then he comes in here, and this looks like he cut that, but it's really an artifact. It's not the intention, it's the artifact. These, on the other hand, are small versions of the big one. that he set inside where there was a void. You think, where did you come up with that? Well, Holtzapfel showed stuff very similar. He experimented a little bit. He duplicated some of Holtzapfel's stuff, and then he applied the knowledge to come back and get this. And hopefully we'll be able to transfer some of that knowledge to other people. I figured that would fill out pretty much an hour, and it's not too far from an hour. And coming really close to the end of the presentation, but we got, I think, one more slide. Oh, yeah. We have a YouTube channel if you want to look at stuff. We avoided using video on this because it always comes across to me as so choppy, but Becky is putting together more and more videos and editing them and getting, you know, she can boil down a couple hours into three to 5 minutes. It works quite effectively on YouTube. We have YouTube. We have our website. Our website has a link to the YouTube channel, and we also have Instagram and Facebook. If you do those things, you can follow those. And she has one more slide in here. And that is her hood ornament in front of the Long Island Sound, not far from the Plumier Foundation, just a couple miles from the Plumier Foundation. And, messing around a little bit with the Photoshop. And she says, have a foxy day.
Very good.
So, any questions? We'd be glad to make up an answer for you.
Okay then, David. Well, that was absolutely fantastic. It really was. I'm sure most people are blown away by the quality of the machinery. And the quality.
Now, if I can figure out how to get back to this, the regular screen.
Yeah. Well, you might
I
need.
took away that little thing there, so.
You worked it out the other night. But you might need to
go. Yeah, well, that was a long
those,
time ago.
You might need to go back to some of those slides if someone has a question. So what I'll do now, I'll invite people to use the raise hand facility, and we'll have a look and see who might have a question there. Right, okay, I've had a question from Rabelais' iPad. Can most of the designs shown be done on the LRE?
Yeah, not the geometric chuck designs, but most of the other designs can be done there. You may find yourself making a rosette with some deeper amplitude, and you know, you hang out with people, and that's going to be happening more and more prominently. I think people will be making their own rosettes a lot more very soon, because we're going to be showing more and more about how to do that.
There was a question.
It functions the same way. I mean, the biggest difference is going to be you don't have the mass you have in the Maid lathe. You have the same motions, you have the same actions, but you don't have the same mass. So fixed tool is not going to be as efficient on the Lindow Rose engine. I've never done fixed tool on it. I know a couple people have done a little bit of it, but nothing in the pictures there was fixed tool work either. I'm hoping to get into that very shortly. Pretty excited about that, actually.
Certainly Al Collins has done some lovely fixed tool work.
I got a lot of catching up to do if I'm going to catch up to Al. I don't think I ever will, actually. But yes, his work shows off the capability of that lathe tremendously. He set the bar pretty high for it.
There was a question from Casey Burns, who's actually had to pop out for another appointment, but rather tongue-in-cheek. He says, David, when will you have the more affordable MDF and 3D printed pot metal version of the Maid lathe available?
the 3D printed version. I wouldn't know how to turn the switch on a 3D printer. So he'll probably be waiting a while for that one.
Yeah, I would think so. Yes.
Hot metal, maybe.
Okay. Well, I've taken off the prohibition on people unmuting. So if anyone has a question, don't all ask at the same time, of course, but you may unmute yourself and ask David a question.
David, the shop looks a lot crowded. I know that you had a bandsaw and some basic woodworking equipment. Can you tell us what you've got in the shop now?
Yeah, you can always go on the workshop section of the website and see that too. We have 4 Holtz-Apfel lathes, 1 Rose engine, 3 ornamental turning lathes. We have 1 John Bauer Rose engine. We recently were given a Lawler ornamental lathe. We have a Maid lathe, and I brought my own Lindow Rose engine down. And then we have various and sundry cabinet making tools, radial arm saw, joiner, table saw, planer. We have a big pattern maker's lathe. We have a smaller Oliver lathe out of a school. We have 2 band saws. And then we have a Bridgeport milling machine and Hardinge HLVH.
Super. Super. Hope you get some good stuff before you run out of space.
We have plenty of space, and I don't think we need a whole lot more, but it's always welcome, but we don't need anything more, so we're not out searching out more things per se. But we have a lot of space left. So it's nice. It's all spread out very, very, very nicely so that a lot of people can gather around each piece of equipment, which we hope to do in October at our fall meeting.
You got to be the luckiest man in the world, David. To be able to do
I know. Can you imagine being married to a woman who put together a thing like this, and that's not even the most impressive thing she's done last week? So I feel very lucky.
I was very impressed with the rope knurling that's on the machine, David. Did you make your own knurling wheels, or were they commercially sourced?
I made the knurls on this. I made the knurler, the knurling wheel, on the Lindow Rose engine. And what you do is you set your drilling frame. If you want a concave knurl, you'd set it vertically, but I tipped it at 30 degrees, and I used a thread mill that's 3/8 in diameter. It's made to do 5/16 wide rope knurls, and I don't remember how many bumps I put on, but you scoop it out, so to speak, with a C-shaped rosette and harden it up, and it cuts more than it mashes, so it actually does a really, really clean job. Frank Dorian, I think he put some pictures of his out there on the net, on his Instagram or something, but several people have made sets of those. We came to that one day at a meeting at my house a couple years back, 2 or 3 years back. And that works really, really nice, actually.
Yes.
I'm glad you noticed that, because from point 1, I insisted on those rope knurls. I absolutely love them.
Yeah, absolutely beautiful. There was a question from Stephen Copestag. He said, could the Maid lathe be made with a 7-inch center height like the plant lathes?
Yeah, I suppose it could be, but we'd have to, make new headstock castings, and you'd have to set out to do that. I don't think we're going to, but it's possible that you could.
Mm-hmm.
We kind of stuck with what was around. The Holtz-Apfel was 6 inches. Armbruster, I think, is a 6 3/8 or somewhere near that, and we kind of stuck with what was there so that things were more interchangeable. You know, the funny thing is I'm always wanting something bigger myself. And this Lawler lathe we just got, my intention is to put 6-inch risers under the headstock. I want to hike that headstock up 6 inches in the air so I can turn some of those Australian burls that are like 20 inches in diameter. Yeah, I'm going to go for broke on these things. The Lawler has enormously massive cutting frames, and I'm going to put it to the test.
Sounds great. A question from Brian Baker saying, "Hi, David. How many Maid lathes do you intend to make over time?" Well, there's a question for you. Yeah.
Well, if you make Maid lathes, you put in a lot of overtime. Sorry. We have 10 production lathes. We've made 6 of those 10, so there are 4 more of those to go. And then there are 4 prototypes, Mike, Al, David, and Eric. We each got 1. So at the moment, the intention is 14 total. But, you know, I don't think it'd take a lot of arm twisting to get us to make more. But we got to sell the ones we have first.
Okay, and Rhys Fleming Allen said, "Will any of the demonstrations at the fall gathering be filmed and posted online for people too far away to make it in person?"
I don't know. I wonder if somebody will probably turn on their phone to a live feed or something like that. I don't think we have the intention of filming during the meeting, because it's we could do the same operation before or after and probably demonstrate it better with a more controlled circumstance. But so we don't really have any intention of doing that, but probably what we're demonstrating we will, but not at the meeting, put it that way.
Yeah. Sounds a good good plan.
The question about making more Maid lathes, you know, I go back to the early days of making these Lindow Rose engines, and I did those with Steve White years ago. And you know, we made one for the 2006 OTI meeting up in Portsmouth, and we figured we'd make a dozen of them. And I assumed that if we made a dozen of them, Steve and I would die with at least 6 of them. You know, because nobody would want them. And then they sold before we were done with the 12. So I said, well, it worked once, it'll work again. Let's make another dozen of them. I figured if we could get 25 of these made, probably half those people would want accessories, and we'd probably be able to have accessories on our own. They were sold before we were done making them. And we did a 3rd batch, and that's when the accessories really started coming out. So who knows what we'll do with the Maid lathe. The labor in those is so intense that we got to catch up getting stuff done. And then once they're sold, we'll think about it, but it's a lot of labor.
Okay, then, David. Well, you might as well stop sharing now, I think, unless anyone's got any final questions.
How do I do that, if you can remind me?
You found it somehow the other day. You went down the bottom left-hand corner, and yeah, and you found the actual option. Yes. Yeah, Tim Schultz has said about your fall gathering, you could launch a Zoom meeting during the presentations to give the remote folks an opportunity to watch. Well, there you go. There's a suggestion for you. Something for you to think about anyway, David. It's similar to us with the SOT. You know, we have 4 quarterly meetings, and hopefully we'll be getting back to those pretty soon, face to face. And people have asked about perhaps doing a Zoom stream from those. So yeah, we're working in that.
Well, there are a lot of options. You can always use like a live feed from Instagram or any of that stuff. But you know, some people don't want to follow Instagram. They want to do something, but you can. It's really effective at that kind of thing. So.
Yeah. Well, that was brilliant, David. Actually, you know, your passion for ornamental turning really comes through there, and the results have been tremendous. And I'm just wondering where Christian gets his skill from. Is it from you, or is it probably from Becky? Is it? I think. Yeah.
I think he gets his artistic ability from his mother, to tell you the truth. He
A
probably
wonderful.
gets his mechanical sense from me and the artistic
Yeah.
from her.
I think it's a wonderful combination. Yes, the pair of you have done a grand job. That's for sure. Yes, great family effort, and yeah, I'm sure it's been enjoyed by everybody tonight. And I said it's been recorded. We've had a question about where's the recording going to be available. Well, the recording will be put on the members only site of the SOT website, but we'll make a copy of that recording available for Ornamental Turners International and for Plumier to put on their own websites. So that should be available to everyone in a little while. It usually takes a little while to sort out some of these videos. We do minimal editing, I would say. We do very little editing at all to these. We don't have anyone with any talent of video editing within the SOT, or no one's owning up to it anyway, because it's just far too time consuming. So